Okay, in this video we're going to talk about finding the slope of a line from a table, and then we'll also confirm that using our formulas as well. So first of all, when we see tables of numbers, those tables don't always have to be numbers that represent a line. We're going to assume that all of these that the points represented in each table here, though, that they all lie on a line. Each table is a separate line, but all of the points in a particular table all lie on the same line. Now that's an assumption that we're making. It doesn't have to always be true. Doesn't mean whenever you see numbers in a table they will always fall on a line, but in these cases they do. Alright, so that's important to state. So what we want to do then is we want to look at the changes. Remember, slope is a rate of change. It measures how much y changes when x changes by a certain amount. So let's see. From the left we can see how x is changing. X seems to be going up by 3, by 3, by 3. So in this case, x is constantly going up by 3, or consistently going up by 3, and y is going to be going down by 6. And so we would say here that the slope is m is equal to change in y over the change in x. Sorry, that's not a 2. That should be a 3. And since it's negative 6 over 3, we simplify that to be negative 2. So the slope in this case would be a negative 2. Now you don't need to do this, but I'm just going to quickly show how we would calculate this using our formula. And so if I pick 2 points, it doesn't matter which 2 points I pick. Let's pick the first 2, and I'll call that x1 and this y1, and I'll pick the last 2 so that it's easy for me to just show these numbers on here. It would be x2 and y2. Alright, so then let's go to our formula. Our formula says that slope is the change in y over the change in x, and so I'm going to plug in my values there. y2 is 2 minus y1 is 20 over x2, which is 13, minus x1, which is 4. 2 minus 20 is negative 18. 13 minus 4 is 9, and negative 18 over 9 is negative 2. So we could have calculated it either way there. Let's go on to the next example. X's appear to be changing. Negative 1 to 1 is a positive 2. 1 to 3 is a positive 2. 3 to 5 is a positive 2. However, the y's are not changing. The y's are not changing. So if I ask you to think about or to picture in your mind a line whose y coordinates are all the same, a line whose y coordinates are all the same, what you should see is a horizontal line, because the y coordinate of each point on a horizontal line is always the same. So let's calculate the slope from that. M is the change in y, which is 0, over the change in x, which is 2, and 0 divided by 2 is 0. If I took no money and divided among 2 people, neither of them would get any money. Would get 0. Both of them would get 0, I should say. Alright, let's try this using our slope formula. So m is equal to y2 minus y1 over x2 minus x1. And I'll always write the formula first because that helps me to memorize it. And I'm going to just pick the first and the last points. We assume that they all lie on the same line, so that would be x1, y1, x2, y2. So you can pick any points, it doesn't matter. And we start by y2, which is 2, minus y1, which is 2, over x2, which is 5, minus x1, which is negative 1 in this case. And we would get 0 over 6. And 0 divided by anything other than 0 is 0. Right? So we showed that whether we calculated the slope from the tables or used our formula, we got the same exact thing. Let's go on to the next example. Now in this case, the x values are not changing. So again, I would ask you to picture in your mind the graph of a line whose x coordinates are all the same. And what you should see is a vertical line. In a vertical line, all points on a vertical line have the same x coordinate. And let's talk about the y's. The y's go up 3. In this case, then they go up 6. And in this case, up 3. So we don't have a consistent change in y that we can measure. Now because of that, we know that they all lie on the same line, so we could use any pair of points there. But what I would suggest perhaps in this case, if you got confused, is to just use the formula. x1, y1, x2, and y2. And let's go ahead and calculate. Well, first of all, I think you should understand that a vertical line, the slope of a vertical line is undefined. So you could have answered this question simply by stating that you know a vertical line, its slope is undefined. And we're going to see why it's undefined in just a second. Alright, y2 minus y1 over x2 minus x1, and y2 is 9, y1 is negative 3, x2 is negative 3 minus x1, which is negative 3, and we end up with 9 minus negative 3, which is 12. Negative 3 minus negative 3, or negative 3 plus 3, would be 0. And unlike 0 over any number is 0, a number over 0 is always undefined. Alright, so 0 over anything is 0. Anything over 0 is undefined. And so the slope of that line is undefined. A vertical line, so let's state it this way. The slope of a horizontal line is 0. The slope of a vertical line is undefined, always. Always. Alright, so we'll go on to some examples of these. Alright, so here we have tables. They're slightly different because now it's a horizontal table, not a horizontal line necessarily, but it's a horizontal table, and the x's are on the top, the y is on the bottom. So we can still try to measure the x change. In this case would be plus 2, plus 2, plus 2. The y change would be plus 5, plus 5, and plus 5. And so we would get a slope that is change in y, which is positive 5, over the change in x, which is 2, and so we'd get a slope of 5/2. Let's calculate this quickly using our formula. We'll call this x1, the last one, x2, y1, y2. So m is equal to y2 minus y1 over x2 minus x1, and we'll fill in the values now. y2 is 25 minus y1 is 10 over x2 is 8 minus x1 is 2, and we get 15 over 6, which both simplify by dividing by 3, numerator and denominator, and so we get 5 halves, which is what we found earlier anyway. Okay, next example here, number 5. Notice what's happening. Something here, the change in x is 0, or we can say that all the x coordinates are the same. Picture a graph whose points all have the same x coordinate. You should see a vertical line. Now that may be confusing for some students because we think of x as running from left to right. However, if all the x coordinates are the same, then it has to be, all those points have to be stacked up and down on one particular x value, and that's going to create a vertical line. Alright, so let's see what the change in y's are. From negative 12 to negative 9 is a positive 3. From negative 9 to negative 6, again, a positive 3. Negative 6 to negative 3, a positive 3. And so what we're going to have there is m is equal to change in y over the change in x, 3 over 0, which is undefined. You can't just leave it as 3 over 0. You have to interpret that that means undefined. Alright, let's calculate that quickly using our formula. We'll call this x1, x2, y1, y2, and so m is equal to y2 minus y1 over x2 minus x1. And so in this case, y2 is negative 3 minus y1, negative 12. Don't just say negative 3 minus 12. It's negative 3 minus negative 12 over x2, 5, minus x1, 5, and we get negative 3 plus 12, which would be 9 over 0, undefined. Right? You can't just leave it as 9 over 0. It is undefined. And it doesn't matter that the first one was 3 over 0 and the second is 9 over 0. As long as it's undefined, it's undefined. Okay, great. We'll stop this video at this point.